Broadcasting from Boston, Massachusetts, the ARC Digital Transformation Viewpoints podcast is the only podcast dedicated to all things related to digital transformation in energy, industrial, and critical infrastructure applications. The podcast is the creation of the ARC Advisory Group Digital Transformation Practice. ARC advises leading companies on technology trends and market dynamics that affect their business. To engage further, please like and share our podcasts or reach out directly on Twitter at ARC_advisory, or please go to our website at arcweb.com.
Hello, this is Harry Forbes from ARC Advisory Group. I'm here today with Michael Martinez, who is the director of the Schneider Electric Foxborough DCS, the global leader. Mike, nice to have you with me today.
Thanks for having me, Harry. Appreciate it.
Mike, we're going to talk today about sustainability and automation. And a lot of times people might think those are orthogonal. They might think that there's not a connection necessarily between sustainability and automation. I bet a lot of the people that work in the automation field don't know their counterparts who are working on sustainability, and vice versa. So can you explain how those two things relate from your perspective as the leader for the automation system at Schneider Electric?
Absolutely. So it's kind of stepping at a higher level. So first of all, Schneider Electric being recognized as one of the most sustainable companies in 2021. One of our primary goals is to help support our customers in achieving their sustainability goals. So a little bit about automation and kind of the history as it evolved through Schneider Electric. So obviously, if you're familiar with us, we've started in the measurement business, measuring processes. We've kind of moved into the control business, control algorithms, PLCs, controllers, and then more recently into the idea of profit engine. So the ability to utilize a control system to not only control the physics, so the flows, the temperatures, and the pressures that we're used to around our facilities, but also to use it as the ability to create profit. So more of a cascaded control type of situation where we set profitability goals that then cascade down into process and safety and maintenance type of objectives. So building upon that now, we get into an era that I like to refer to as responsible profitability. And this is where we're enabling our end users to safely and effectively make the most of their energy and resources, where they have a positive impact, not just to their organizations and their customers, but also to the communities in which they operate and serve. So what does that mean from an automation perspective? That means that we've learned over the past few years in terms of talking with customers is that there can be multiple variables by which they measure success. Historically, we think profitability, and it's all about profitability. But if you've been paying attention recently, you've heard about ESG scores, greenhouse gas reduction and such. And so there become these additional variables that we want to be able to control with to allow our companies not just to continue to produce the products that our customers need, but also to come more in alignment with some of these social responsibilities. And so if you look at how that's being enabled with our automation system platforms today and in the future, it really is about digitization, getting the information we need digitized. Sometimes they're in site classes or sometimes they're relative. The other is actually integration. So the ability to get that information from the source to wherever our automation platform is so that we can get it in front of the management and the operations to make those timely decisions, whether it's looking at analytics, giving them some sort of guidance or some sort of artificial intelligence or machine learning that allows that to be directly incorporated in the control algorithms. This helps our customers now to achieve, as I said, not just that profitability, but also now these additional success variables.
Okay, Mike, these are kind of broad concepts, and I wanted you to give our audience one or two examples of customers who've done concrete things in this area that you think we should take a look at.
We've actually seen some examples of that in some of our EcoStruxure power and process, where we integrate process control with traditional power and energy management, 61850 type of networks. We've gotten customers who've started in the design phase. I know one of our biodiesel refinery customers who was actually able to reduce the geographical size, so the footprint of an e-house and the total installed cost by over 15%, just by considering the idea of consolidating and integrating these systems. Additionally, from an operational standpoint, we've had customers in the specialty chemical industry here in the U.S. who, after integrating the power and process systems, was actually able to identify 3 undersized variable speed drives that had been causing some downtime, which obviously comes with additional cost and unnecessary equipment aging, as well as synchronization issues between voltage regulators and imbalanced pump utilization in some of their columns. So this gave them the information that they needed, that they didn't get just back from the physical variables, to now make better operational decisions and address, it could be energy, or it could actually result in some unplanned outages.
Okay, well, Michael, you talk about what you're talking about here in a way is giving an automation system a broader charter and a broader view of what's going on in the process in sense of what are today more considered business variables that are not part of the operational or the automation system. So what types of additional information do you think end users are going to need to develop these kind of more broad-based objectives for their automation systems, and where's that information going to come from?
Well, right now, I think one thing's becoming very apparent to us, regardless of industry, is that the speed of information is the speed of business, right? So it used to be that we could get information from sources like the newspaper or the Wall Street, the ticker, to identify stock prices or the cost of raw materials and such. So the first thing is exactly the integration of this, right? So that's one piece. The other piece is what types of information are we going to be looking for? So I think if we look at traditional business, we're really talking about things like energy consumption, material cost, labor cost, shipping or storage. It used to be that inventory was a bad word. These days, it's becoming a necessity. So storage costs, shipping costs. So these types of things to be able to manage our business. But as I was mentioning earlier, there is an extension of that now beyond the traditional profitability metrics that we might use to get business. So looking at information like in emissions information, carbon emissions, greenhouse gases, or things like customer perception, things that can be digitized, where you can take surveys, get information on perception, or stock prices or ESG scores, things that can then be utilized to either set risk constraints on our process operations or even in some instances drive that. And so those will come from multiple sources. I guess the biggest thing is finding the good system of record that most represents your business and ensuring that they have that information available in a digital format.
It's interesting from what you're saying. It sounds like a lot of those things are going to come from different areas of the business, and what the production management people are going to need is kind of a dashboard, if you will, into these kind of things, almost as if they were measurements.
Absolutely. I mean, if you look at how we make decisions today, as I kind of started to say earlier on, is that we used to do quarterly reporting. So we would get this summarization of not only the business inputs, the value of the product that we sold to our customers into the market, the labor costs, all of these things we used to look at on a quarterly basis, and then redirect our businesses in that time frame. As business has become more available, we keep adjusting that time constant to be faster and faster and nearer to real time.
Got it. So, Michael, how do the automation systems of today measure up to these kind of new capabilities that you need in supporting the new multiple objectives that include sustainability? How do today's automation systems stack up against that?
Well, I would say they're semi-capable and they're getting more and more capable. I mean, I think if you look at the systems today, most of them are built around proprietary protocols and platforms and software. And so there's this need to create drivers or connectors or pieces of technology to link, one system to another, or formatting concerns where you have to change the format of a piece of data to get it in the right format for your control system to consume. I think if we look at where we are today, obviously a big drive towards OPC UA type of standard-based communications and networking that are helping to further this state of integration, so that allow us to, at least at the most primitive level, speak a common language from a data perspective to get the information in. And then you're seeing organizations like OPAF and Universal Automation that are driving us more towards that open and interoperable vision, not only from a data standpoint, but also in many instances from a hardware standpoint as well. So the capabilities are there today, I would say, in infancy, and they're continuing to grow probably very rapidly over the next few years.
One thing I would mention, you mentioned universal automation. Our audience may not be familiar with that concept, but in a nutshell, correct me if I'm wrong, but their objective is to create a common software runtime environment for automation, which is something that the IT world has had for many years, and several different kinds of runtime environments that people are familiar with, starting with Windows or whatever, but a number of runtime environments which automation systems really haven't had, and they're trying to develop that based on the work that you have in Schneider Electric, basically sharing that. Isn't that correct?
That's absolutely correct. I mean, one of the things that we've kind of seen through the years is we've all kind of, and many of the vendors and many end users have been participating in OPAP, so open process automation. The standards, while they set the basis, I think universal automation takes that next step and actually provides a real runtime to develop applications that can start to move towards creating a real life OPAP system.
Okay, well, you see that as a next step. Let's take that a few steps further. What kind of things do you think will be evolving in the automation systems area to enable these ideas of sustainability and responsible profitability to prosper?
So one, I think I kind of touched on with OPAP is this notion of open, portable, cyber secure, hardware dependent. I think right now we're looking at the automation systems being very specific and everybody having to create their own unique applications. And so we kind of have these different flavors. I think the other thing is, pointing directly towards the reality of universal automation is that we need to help customers get additional efficiencies in their own operation. So it's not just, as I said, if we look at these other variables, it goes beyond profitability. So what are some of those things look like? I mean, it could be breaking down silos in their own organizations, because right now, a lot of times customers or end users organizations are structured around their technology choices. And so they may have one organization responsible for PLCs, one for DCS or distributed control systems, one for safety. They may have different organizations split up based on the vendors that they've selected for these types of systems. And so having one standard integrated development environment that can support this open portable concept with that's independent of hardware now enables them to say, well, let's have one process automation organization where we can develop one set of tools and one set of applications that can be deployed across multiple types of hardware. The other thing that this allows us that I hadn't even really considered until we had recently started talking about more about ESG scores is that it really does, from a diversity standpoint, allow you to leverage a larger, more diverse pool of expertise and resources. I mean, today, as I said, having these proprietary systems really requires you to say, well, I have this vintage of vendor X and this vintage of vendor Y, and look for a very select, limited number of people or resources that you can actually utilize to get value or to work on those systems today. This will allow employers and end users to be able to expand that, and as well as, from a workforce perspective, give people who want to get trained and work in this industry of automation and process automation a set of tools that they can develop that can be more broadly applicable. So giving them exposure to more potential employers. And something else that there again we'll hit home specifically today is it'll enable us to have a more distributed and scalable supply chain. Because if you have an application that you can build once and deploy many times independent of hardware, now you can start to, as an end user or provider of goods to your customers, start to stand up facilities or factories closer to your users, right? So that we are limiting now our exposure to disruptions in supply chain, bringing them closer to the point of use, and we can do that in a more modular and scaled way with these systems of the future, as I say, kind of based on universal automation.
Okay, you talked about the software for such an automation system or future automation systems and the hardware independence that they're going to have, or a greater degree certainly of hardware independence. So to support this, there's certainly always going to be an automation infrastructure, however it exists. What kind of automation infrastructure do you foresee will develop? And I'm asking this question from both a software standpoint, which we've touched on, and a hardware standpoint, which we haven't. So if you go way out into the future where we have these kind of systems that are much more broad-based and also much more standardized and built using kind of converged IT and OT technologies, what are these going to look like from a hardware and software infrastructure standpoint, in your opinion?
Yeah, so since I've talked about software a little bit, let me start with hardware. So some of the things, and anybody who has participated in our innovation days is familiar. I've talked about this in terms of the future of EcoStruxure, Foxborough, DCS. But we're really looking at taking some of the leading trends in hardware in terms of Ethernet everywhere. I think we're starting to see more and more as we get more intelligent, more connected devices. It's going to be necessary to have that capacity and that bandwidth to be able to get the information from these connected devices, as well as to look at this less centralized architecture that we're so used to now, and a truly more distributed. I think that's another thing that's happening right now is a redefinition of distributed control, in having some of the control elements further at the edge. So far, even as having intelligence running or control strategies running in transmitters, in pumps and other devices like this, as they continue to get that internet connectivity and they continue to grow in their compute capacity. I think something else is the standardization of our ability to have a common network. As I said earlier, I think OPC-UA is kind of driving this and looking at the OPC-UA time-sensitive networks as a basis to say, okay, this is what we're going to build upon as an infrastructure. OPC-UA standards, they're again like field level communications and the PA DIN, so that the device information model. I think working with these standards will give us the most flexibility, and for the end users, it creates an opportunity for all of the vendors to play in a common way and communicate in a common way that we can be structured in, that doesn't make the end user reliant too much on one vendor. I would say also something else we see coming from a field instrumentation perspective primarily is the advanced physical layer, right? So this is where you're able to supply power and communications over a single twisted pair. So this not only allows us to utilize some of the wiring that we currently have in the field, which could be a costly change for many customers if they had to go and redo that, but it also allows us to now take that instrumentation, so what we traditionally do, power over Ethernet, and now put these into areas where you have explosion hazardous areas. So we believe that the combination of these Ethernet standards, the time-sensitive networks, and APL will give us the physical layer that we need to now connect what we see as the next generation of intelligent devices, allowing customers to have, as I said, a broader capability in terms of how they structure their automation systems. As I said today, a lot of times they're centralized and the I/O is bound to the controller. In the future, with an infrastructure like this, we see unbound I/O, multiple controllers with multiple vendors. As I said, getting back to the software, being able to be an application that can be configured in one integrated development environment that can run on all of these devices that are tied to this OPC-UA TSN network, and now give our customers new ways to think about scalable, but also what we call scalable availability. Because today, when we think about fault tolerance and redundance, we think about having two of everything, which works, right? But now in this new paradigm of having everything on an OPC-UA TSN network, having the ability to distribute an application across all the compute capacity available on the network, now you can get to the point where you can utilize, say you have a simple control loop that's running in a transmitter and connecting directly to a valve. That control loop can actually run in the transmitter and right to the valve over that network. If there, for some reason, we need to replicate that or duplicate that or move from one transmitter to another, it's simply a software move, right? So it's changing that loop from running in one of those devices to another one of the devices already on the network. And so we start to think about now adding that N plus N type of redundancy, as opposed to our traditional redundancy of duplicating everything. So I think it's going to give us an opportunity to look at things in new ways. And one of the things I'm most excited about the future as we kind of look at and kind of wrap up this vision of this hardware and software future is that we really want to get back to kind of where when I went to university to understand our customers' processes. And I think right now, as we've seen systems evolve over the past few decades, it's become more and more imperative for our customers to choose a hardware platform and thus dictate how they operate their facility. I think we're getting to the point where we can now sit down with end users, with customers, and understand what is the best way to operate their process given this new set of constraints, whether it's environmental, carbon emissions, greenhouse gas, whatever it may be. Design the process in that way and then deploy the appropriate technology, both from a robustness standpoint, so making sure that the equipment is fit for the environment that it'll be in, but also in the ability to develop designs that take cost into consideration as well. Because as we start to look at these open systems, in some instances, a lower cost, less environmentally constrained piece of hardware may be appropriate for one application and not for another. So now you can start to bring the right hardware to bear to address the customer specific challenges.
One thing that you said that really struck me was the customer's ability in the future to be able to pick and choose from a much larger array of products and solutions to work on these broader sets of objectives. And I should think that would have some impact on suppliers like Schneider Electric in this area too, and that the prospect of these more hardware independent and open systems lets you deliver something much more customized for each customer rather than just taking the existing product line that you have and making it fit.
Well, absolutely. I mean, if you look at Schneider's overall vision, we want to enable our customers to make the most of their energy and resources, right? And part of achieving that means that we need to provide the technology that enables that. And in some instances, that means being able to include solutions that are ours, or not only ours, but maybe from multiple different product families. As I said, PLC IO, or integrate directly to a drive or to an energy management system or to a building automation system or to one of our UPSs for energy storage and energy management. I think the idea is being able to bring the appropriate tools necessary, even extending automation beyond automation, as I said, to some of these business systems and building management systems and energy management systems, to really look holistically at how we can help our customers achieve. I mean, tying it back to sustainability. As I said earlier, one of our primary focuses, other than sustainability being a key value for Schneider Electric, is to be a sustainability partner for our customers to ensure that we can provide the technology and solutions necessary to help them achieve their sustainability ambitions.
So, Mike, if a customer wanted or a potential customer wanted a little more to take a deeper dive into this area, where would they look, or where would you suggest that they start looking?
So a couple of places. So one, obviously, you can follow Schneider Electric at se.com. A lot of information there in terms of not only about our products, but some of these core values of our company. And the other, I just say follow me on LinkedIn. I mean, I'm one of the obviously, you can probably hear the passion in my voice. I think I'm a big advocate for where we are from a sustainability standpoint, the investments that we're making, and kind of the way that we're partnering with customers. So follow me on LinkedIn. I'm constantly sharing information, and not only that, start a dialogue. I mean, I think as I'm open to share whatever you're interested in knowing, and hopefully get the opportunity to pursue some of these sustainability initiatives together.
Mike, thanks very much. It's really been nice talking with you.
Appreciate it, Harry. Thanks.
My guest, Mike Martinez, who is the global leader for the Schneider Electric Foxborough Distributed Control System, and talking about sustainability. Mike, we'll talk again soon. Thanks very much.
Bye-bye.